Hi one and all, this is Steven from Aeronautical Engineering branch. Today I am here about the concept video of basic electrical engineering. My topic is about applications of source transformation. Let's go into the topic. Source transformation. Source transformation methods are used for circuits simplification to modify the complex circuits by transforming independent current sources into independent voltage and sources and vice versa. To analyze the circuits, we can apply a sample voltage and current divider techniques by using these transformations. This source transformation method can also be used to convert a circuit from Thevenin's equivalent into Norton's equivalent. Let us know the source transformation methods in brief. Let's discuss about practical voltage source. An ideal voltage source means a device that offers a terminal voltage which does not depend on the current flow through it. But such ideal sources never exist practically. Suppose a battery would produce 12 watt when no load is connected or no current flows through it. Then the battery produces a less voltage than 12 watts when a load current flows through it. These sources are called as practical voltage sources. However, as long as small power or currents drawn from the load, these practical sources represent the ideal voltage. Take a minute into this picture. And next, characteristics of practical voltage source. Therefore, the real model of device is obtained by an ideal voltage source with a series resistor. This series resistor resembles the voltage drop in the device when the current flows through it. The series transistor is called as the internal resistance of the voltage source. This does not mean that we can find such an arrangement inside every practical source device, but merely represents the reduction in terminal voltage on an account for an increase of load current flow. Take a minute into this picture. This picture is about practical voltage source with internal resistance. Practical current source. Similar to an ideal voltage source, an ideal current source also never exists as there is no device or source that delivers a constant current independent of connected load resistance or the voltage across the load terminals. However, if the load voltage is small, load current in practical current source and current from ideal current source are equal. Therefore, a real model or practical current source is obtained from an ideal current source in parallel with resistance or internal resistance. This resembles the current changes in a practical current source with change in voltage of the load or change in resistance of the load. And take a look in this picture. Concept of source transformations. Consider both practical voltage and current sources with load resistance of RL. Let us see how the current behaves for resistance change at the load. If the load resistance RL is equal to 0 in practical voltage source current, then the load acts as a short circuit, and in the short circuit current flows through the load. So the VL is 0, VL is equal to IL into RL, and the IL would be IL is equal to VS by RS. Here similarly for RL is equal to 0, practical current source circuit, load also behaves as short circuit as it prevents the current flow through non-resistance path. This load current is equal to the source current which is equal to the value of Vs by Rs in practical voltage source circuit. Therefore here Is is called Vs by Rs when RL is called 0, and here RL is called 0 in practical current source circuit. The load behaves as short circuit. The load current is equal to the source current, and here if the load resistance RL is called infinity, both circuits behaves as an open circuit. Therefore the load current is 0 in both circuits, and the voltage drop across the resistance rent in practical current source circuit is Is into R int V int is equal to Is into R int. And the voltage across the RS in the practical voltage source current circuit is equal to the Vs, which is equal to the Is. R int of the practical current source circuit, Vs is equal to Is into R int when RL is infinity. Hence from equation 1 and 2 we get Vs is equal to Rs into Is, Vs is equal to R int into Is. Here we are getting two equations and we are solving. By observing above two equations, if the internal resistance of the two sources is same, when the two sources are electrically equivalent, these two sources are equivalent, they can produce the same values of IL and VL when connected to same load resistance. By observing above two equations, if the internal resistance of the two sources is same when the two sources are electrically equivalent, these two sources are equivalent, they can produce the same values of IL and VL when connected to same load resistance. If the load resistance RL is infinity, both circuits behaves as an open circuit. Therefore the load current is 0 in both circuits, and the voltage drop across the resistance R in practical current source circuit is Is into R int V int is equal to Is into R int. Hence here we are these equivalent sources can produce identical values of short circuited current and open circuit voltage when zero load resistance and infinity resistance respectively. Therefore, by interchanging the internal sources resistors, we can transform their properties from current source to a voltage source and vice versa. Source transformation is a process of simplifying a circuit solution escapically with mixed sources by transforming voltage sources into current sources, and vice versa using Thevenin's theorem and Norton's theorem. And here source transformation is a process of which circuit solution escapically with mixed sources by transforming voltage sources into current sources. This vice versa is taking place through the Thevenin's theorem and the Norton's theorem. And the source transformation is performing of consists of using Ohm's law to take an existing voltage source in series with a resistance and it replacing it with a current source in parallel with the same resistance or vice versa. It will be taking place. The transformed sources are considered identical and can be substituted for one another in a circuit. However, this means the source transformation is bound by the same as conditions as Thevenin's theorem and Norton's theorem, namely that the load behaves literally and does not contain dependent voltage or current source. And source transformation is used to exploit the equivalence of a real current source and a real voltage source, such as a battery. Here, the applications of Thevenin's theorem and Norton's theorems give the quantities associated with the equivalence. Specifically, given a real current source, which is an identical current source, I in parallel with an impedance Z. The Thevenin's theorem and the Norton's theorems gives quantities with associated equivalence. Here we are applying the source transformations gives as an equivalent real voltage source which is an ideal voltage source in series with the impedance. The impedance Z retains its value and the new voltage source V has value equal to the ideal current source values times the impedance. According to Ohm's law, V is called I by Z. It takes place in and here in the same way the ideal voltage source in series with an impedance can be transformed into an ideal current source in parallel with the same impedance where the new ideal current source has value I is called V by Z. Here an ideal current source in parallel with the same impedance, the ideal current source has a value is called I is called V by Z. In the same way an ideal voltage source in series. And here the source transformation are easy to compute using Ohm's law. There is possible to find the value of the equivalent current source in parallel with the impedance by dividing the value of the voltage source by the value of the impedance if there is a voltage source in series with an impedance. Here the transformation can be derived from the uniqueness theorem in the present context. It implies that the black box with two terminals must have a unique well defined relation between its voltage and current. It is ideal to verify that the above transformation indeed it gives the same VI curve and therefore the transformation is valid. And here the converts also holds if a current source in parallel with an impedance is present. Multiplying the value of the current source with the value of the impedance provided the equivalent voltage source in series with the impedance. A visual example of a source transformation. And here multiplying the value of the current source with the value of impedance provided of voltage source. A highly valuable byproduct of Thevenin's and Norton's theorem is the technique of source transformation. Source transformation is based on the observation that if a Thevenin's network and Norton's network are both equivalent to a particular source network, then they must also be equivalent to each other. And here this observation allows you to simply an analysis by converting a voltage source with series resistance to an equivalent current source with parallel resistance or vice versa. And just taking place as the parallel resistance or the vice versa. By observing the voltage source with series resistance to an equivalent source. And your source conversion may be applied to portions of a circuit to simplify intermediate calculations. Going even further, repeated source conversions may reduce a circuit to all series or all parallel form. And here intermediate calculations, the application of portions of a circuit is may be of source conversion. Conversions may also be applied to controlled sources as well as to independent sources. And here the converts also holds if a current source in parallel with an impedance is present, multiplying the value of the current source with the value of impedance provides the equivalent voltage source in series with the impedance. And here a visual example of a source transformations. The transformations can be derived from the uniqueness theorem. In the present context, it implies that a black box with two terminals must have a unique well-defined relation between its voltage and current. It is readily to verify that the above transformation indeed gives the same VI curve and therefore the transformation is valid. Here the highly valuable byproduct of Thevenin's and Norton's theorem is the technique of source transformation. Source transformation is based on the observation that if a Thevenin's network and Norton's network are both equivalent to a particular source network, then they must also equivalent to each other. This observation also used to simply an analysis by converting a voltage source with series resistance to an equivalent current source with parallel resistance or vice versa. The source conversion may be applied to portions of a circuit to simplify intermediate calculations. Going even further, repeated source conversions may reduce a circuit to all series or all parallel form. Conversion may also be applied to control source as well as to independent source. Thank you all of you. Thank you for giving this opportunity.